Okay, so now to measure the latent heat of fusion of ice, we're going to use the same calorimeter. It's going to have some warm water in it now because we want to melt the ice in a reasonably short time, but not too hot so that we don't lose too much heat through the walls of the calorimeter. And then in this cooler, I have some ice I took out of the freezer a little while ago. That's important because our freezer here is just a regular household freezer on a fridge, but it's set at much colder than zero. So our ice in there is actually, um, it's like minus 15 C or something like that. It's pretty cold. So what I did is I took some out a little while ago and put it in this cooler to sort of warm up. And now I can see the ice is just starting to melt. It's been in here for a while, so I'm pretty confident that the ice is pretty close to freezing point and not too much colder than that. Like I said, it's starting to melt on the surface, but also there's just a little bit of ice in there in this big cooler, so there was a lot of air to warm up, and it's had a while to sort of reach equilibrium, and it's just starting to melt. So I'm pretty confident that that's at 0 C. So we're going to use that for a starting temperature. So now I'll kind of talk through our sort of measurement situation so you can draw your picture for number one. So our initial situation is going to be the cup, the calorimeter, with a known mass MW of water in it at a warmer temperature. It'll probably be around 30, 35 C. And then what I'm going to do is take a paper towel and pick up a little bit of ice, kind of try and dry it off quickly, and then I'll have a mass of ice MW that's at freezing or 0 C. And what I'm going to do is on the balance, I'll add the ice to the water. So we'll weigh the ice basically when I put it in the water. But our starting situation is this warm water in the cup, and a mass of ice that will be added that's going to be at 0. Now, for our final situation, what's going to happen is I'm going to put the ice in the cup. The ice will melt in the warm water, and then the thing that we have to keep track of is the mass of water in here from the melted ice. Because, say the water's at 30 C, we put the ice in there and it all melts. Well, the water will have cooled off a little bit, but we'll also have the water from the ice melt, and that will have to warm up to reach the equilibrium temperature. So there's sort of, you can think of this as like a two-step process towards equilibrium, where first the ice gets melted while the water cools down, and then that residual Mi of water, is going to be water at that point, but it will be the same mass as it was when it was frozen, is going to have to warm up to the equilibrium temperature as well. So our final situation is we're going to have Mi plus Mw of water in here at some final temperature Tf. And so since we know that ice is at freezing, we can just use a single thermometer to measure everything. And I'll go ahead and get that ready right now. So, as I mentioned, we've got the same calorimeter from before. The scale is still tared out from the initial weight of the cup. So when I put this on here, the mass of the water right now is 126.14 grams. So that's our warm water for number 6. MW is 126.14. And now what I'm going to do is get the thermometer back in there so we can get a temperature of the water before I add the ice. I'm going to pick up maybe 2 ice cubes and just wrap it in the paper towel for a minute. And let's see. So on the acquisition system, it looks like our water is at about, what is it, 34.6 C. I'm going to start recording over there. Okay. So we've got our water at 34.64 right now. I'm going to get ready to add the ice. We'll keep an eye on balance here. So there's our mass of water, and put the ice in. And so a mass of the water plus the ice is 151.69. So now I'm going to cover this up, start stirring, and we'll give it a little bit to melt. Keep an eye on the temperature. Okay, so we can see our temperature dropping. And basically we want to kind of look for a minimum in the temperature. It's going to take a little while to melt the ice and warm up the water in here. But once the whole thing starts kind of warming up a little, right now it just crossed to below room temperature inside. So that means it's going to be, gaining some heat from the environment. So once we see the whole thing warming up, we'll know the process is done. So let's see. Try not to stir too much, but I do want to keep it mixed so that it melts quickly. Maybe take a little peek in there once it looks like we might be close. But we're still cooling. Okay, not too much action now when I'm stirring. So I'm going to take a look and see. I don't see any visible signs of ice in there. So now I just want to make sure the water is all mixed and at the same temperature to get the final reading. Looks like I've got a pretty good line there, 15.6. Now it's kind of starting to head up, 15.61 and 2. So I think our 15.6 is probably a good value for the final temperature. Put a little cursor there. And let's see, this would be our initial temperature right here. This is where I took the thermometer out of the water to add the ice, so we don't want to count this part, but our initial temperature of the water would be right here at 34.5 C. Initial temperature of the ice was 0. And then our final temperature was 15.6 C.